Hi everyone, in this new chapter on normal distribution, it actually is under topic 17 for H2 students as well as actually topic 11 for H1 students. In this video clip on the introduction to continuous distribution, I'll be sharing to you a different type of distribution as compared to what you have learned previously. That is binomial distribution, which is a discrete random variable. Now in this chapter, let me first introduce to you this particular important term that is called the probability density function. Now it's important to actually understand this concept of probability density function, though the exact probability density function of the different distribution is not required. Now in this probability density function, basically it's just a curve, okay? And this curve actually gives you a rough idea about what are the probabilities that x values from, let's say, 1 to 3. For example, this value is say 0, 1, 2, and so on and so forth. So if you want to find the probability that x is between 0 to 1, then of course we'll be looking at this area here. So in the case of a continuous random variable, we are interested in finding the probability that x is between a certain range of values. And to do that is actually to find the area under what we call the probability density function. Now the probability density function, which we usually denote as small f, is actually a non-negative function. And it is actually going to be greater or equal to 0. That is one of the important conditions that is given in your notes. And the other condition is that the integral of the density function from the minus infinity to plus infinity will always be 1. Okay? Something similar to the probability distribution function, okay, for the discrete random variable. Now, besides knowing some guidelines about the probability density function, you also need to know how to find the definition of what is expectation. The expectation of a random variable, just like in the case of a discrete random variable, is the average value of x. And knowing that expectation of x is given by x times the density function. Okay? And that is the expectation of x. And the variance of x is of course given by minus infinity to infinity x minus expectation of x, okay, square times small fx dx, which can actually be reduced or simplified to this form. Where mu is the expectation of x. Okay. You do not need to calculate the expectation and variance using integration, but you will need to know, of course, that how to find the expectation of some linear combination of the random variables. Okay. To do that, that means you need to know some properties of expectation and variance. The first property is the expectation of A is A. Okay. All these properties works as well for the discrete random variable. But the only difference is that for continuous random variable, questions which requires this property becomes quite obvious. That means you need them to actually do some of the problems. Then the expectation of AX, where A is a constant, is given by A expectation of X. This is true for both discrete and continuous as well. And then the third property is AX plus or minus BY can actually be given by A expectation of x. If this is a plus, this will be a plus. If this is a minus, this will be a minus. B expectation of y. And the fourth property, of course, is a more general property that says that if you have two functions, okay, and you want to add or subtract the expectation, it will simply be expectation of fx, okay, plus, capital X, plus the expectation of gy. Okay, regardless of whether x and y are independent or not. Comes to variance now. Now for variance, Likewise, for the continuous random variable and discrete, it's the same thing. The variance of a constant is 0. Okay? And the variance of a times x is going to be a squared variance of x. So for expectation and variance, the difference is that when you want to take out the constant out from expectation, it's just a times expectation. Whereas for variance, when you want to find the variance of 2x, it will be 2 squared variance of x. Okay? And the third property is that the variance of ax plus or minus by, okay, it can be written as a squared variance of x. Regardless of whether it's a plus or minus, it will still be a plus, b squared variance of y. But the last property here is only true if x and y are independent random variables. Okay? Okay? They are independent. Okay? Now let's take a look at an example, okay, that comes with it, which I'm going to show it to you. Now, let's take a look at the example. You may want to copy down this example. Okay, we let x, okay, and y be two random variables, or two independent random variables, sorry. Okay, such that expectation of x is 3, okay, and variance of x is 4, and expectation of y is 2, and the variance of y is 1. Yeah. Okay. Our aim is to find, okay, part 1, the expectation of 2x minus 3y. Okay, and part 2 is to find the expectation of x1 plus x2 plus x3 minus y1 minus y2. Now, when you write in this way, it means that x1, x2, x3 are 3 independent random variables for x, and y1, y2 are again 2 independent random variables of y. That means they follow the same expectation and variance of x and y. And for part 3, we want to find the variance of 2x minus 3y. Okay, and part 4, the last part, is to find the variance of x1 plus x2 plus x3 minus y1 minus y2. Okay, we are looking for these 4 values. Now, in the first situation, we want to find the expectation of 2x minus 3y. Regardless of whether x and y are independent, you can actually write in this way: 2 expectation of x minus 3 expectation of y. But we know the expectation of x is 3, given the question, and the expectation of y is 2. Okay, so you can, sorry, this is 3 also. And therefore, 6 minus 6, that gives you 0. That is the expectation. Now, how about the part 2? To find the expectation of x1 plus x2 plus x3 minus y1 minus y2. Now, you must understand that when you say x1 plus x2 plus x3, it's not the same as saying it's 3x. Because x1 plus x2 plus x3, I give a quick example. X probably is the random variable for the weight of an individual. So if you have x1 plus x2 plus x3, it means that we are taking the total weight of 3 persons that is chosen randomly. Whereas if you compare it against 3x, it means it's just 1 person's weight you multiply by 3. So there is a difference. Okay? But in terms of expectation, if you break it up into this way, okay, minus the expectation of y1 minus the expectation of y2. In terms of expectation, they are all the same. All three have the same expectation, which is 3. So it gives you 9. Minus expectation of y is, in this case, 2, so minus 4. So that gives you 5. That is part 2. Let's look at part 3 now. You want to find the variance of 2x minus 3y. Now we are given that x and y are independent random variables, so we can actually break it up. Take note that even this is a minus, this will always be a plus. Okay? So it gives you 4 times the variance of x, which is 4, plus 9 times the variance of y, which is 1. Okay? And 16 plus 9, that gives you 25. Okay? That is part 3. Now let's take a look at part 4 now. We want to find the variance of x1 plus x2 plus x3 minus y1 minus y2. You again can split up into variance of x1 plus variance of x2 plus variance of x3 because they are independent plus variance of y1 plus variance of y2. Okay. Now each of the variance of x is 4, so 4 times 3, that gives you 12. And each of the variance of y is 1, so that gives you 2, so it gives you 14. So that is how we actually calculate the expectation and variances of the linear combination of random variables using the properties of expectation and variances, and which of course is important for your this particular course, whether it's H1 or H2 students. Thank you.